What I'd like to do is to just quickly go through these exercises and see what approach you took to solving them. So let's start with the first one. The first one was find out which Linux distribution you're running. And we talked about Linux standard base yesterday, LSB, and how it comes with a standard for different releases and what tools to include. One of the tools that will often come with an LSB distribution is an LSB release command. So you should have been able to locate that, especially if you're running Ubuntu. I think it should be bundled with Ubuntu. What did you do in order to print the name of your Linux distribution? What command did you run in your terminal? Can you tell me that? It's not just LSB release, because if I do that, whoops, caps lock on. I get the LSB version on my system, but nothing else. LSB release ID, says Sydney. That'll give you the distributor ID, which will usually be the name of the organization that provides the distro. There is a command that will list everything. Well, let's see now. Johan says D. That'll give you a description of the distro, and that'll usually be a string that contains the name of the distribution. In my case, Arch Linux. What you can also do is to run -A, which will give you everything. In my case, I have a distribution with a rolling release, which means that it doesn't really have a version number. As soon as any package gets updated, I just get the new package. In Ubuntu, you should have a very definite version number or release number. Levendal says that he looked through Etsy and he grepped for LSB release. Let's try that. And on my distribution, that doesn't bring up anything. However, I do have some release files, and on my distro, they're called Arch Release, LSB Release, and OS Release. And if I cat those files, and I can do that by catting every single one of them with a glob, and we'll look at globs later today, I get all of the information that we already saw. Very good, guys, very good. On to the next problem, which I basically solved just now. What do you do if you don't have LSB release? Well, you can look through Etsy and there should be some release files. And I just showed you how you can grep. Use grep to filter out the files with release in their name. And we used a pipe to do that, and we'll talk more about file redirection, input redirection later today. This is an instance of redirecting output from one program, i.e. ls, into another, in this case grep. Okay, let's move on. Number 3, I wrote, use your package manager to install a few programs, Cowsay, Fortune, Figlet, etc. Did you figure out what all of those programs do? All of them should come bundled with their own man pages. And of course, another way of figuring out what they do is to run them. Can you quickly tell me what the first couple of them do? The Cowsay and Fortune, what do they do? Pretty small applications, these. They're mostly for fun, but they are part of Linux lore. You find them in a lot of package managers, just because people know about them and people have used them for years. Anyone? Fortune returns a random epigram. Yes, it returns a random small pithy saying, the kind of thing you might find in a fortune cookie from a Chinese restaurant. Not sure if you get those in Johannesburg. They're very common here. Go to a Chinese restaurant, they give you a fortune cookie at the end, a small crispy biscuit, and you open it, and inside there's a roll of paper. Well, they've expanded Fortune in Linux to be more than just fortunes. It contains quotes and funny sayings and jokes. So if I bring up the terminal again, oh, I don't have it locally. Let's see if I have it on Ubuntu. Fortune. And big book, big bore. Okay. Not sure if that relates to me or not. Okay, and what about... so you do have fortune cookies in Joburg. That's fun. It's interesting how the Chinese community has these commonalities across different countries. Now, a cowsay displays a cow doing things. That's right. So cowsay is basically just provides an ASCII frame around whatever you provide as input. So if we do fortune and we pipe it to cowsay, we get a funny saying said by a cow. And let me see here. Okay. Now, did you figure out how to change the cow for something else? That was basically an exercise in reading the man page. Yep. Okay. So if we read the man page for cowsay, it doesn't tell us directly, but it talks about cow files. It says here at the end, the F option specifies a particular cow picture file. And the question is, how do we find which picture files we have installed? And it says at the end of the paragraph, to list all of them, invoke cowsay with the -L switch. And if we do, we get a ton of options. And one of them is called Vader, which sounds very relevant to the question at hand. So if we now do cowsay what was it? F, Vader, and we need to provide some input. We'll do that with some nice redirection here. Hello. Pipe it to cowsay. We get a Vader cow saying, Cowth Vader, saying hello. And Johan said fortune, pipe, cowsay-F Vader. Very good. That's exactly what you do. Okay. Onwards and upwards. Number 4. Make sure Git is installed. If you do not have it, install it. I'm sure that most of you have used Git already, so you should be familiar with the tool. Which is why I chose to include that in this exercise. Then I told you to create a new directory using makedir and then run git init. Did you figure out what git did to the directory? That's the question. What did git do? So if we open a terminal and let's switch to a directory meant for tampering with, let's make a directory and call it git there. Git directory. Enter it and run git init. We then get an empty Git repository And Johan is saying it created a secret dot file called .git. Okay, let's have a look. Let's run ls-la, which we looked at yesterday. And yes, there is a .git directory. It's not just a file, it's actually a directory, and we can of course inspect that directory. And it contains a lot of things that you might recognize from Git parlance. It contains a directory called branches, a directory called objects and refs, and it even contains head, which you might recognize from problems like having a detached head or being in a detached head state in Git. So yeah, the internal state of Git is found inside the hidden .git folder, or .git directory is what I ought to call it. Very good. And that's exactly how an empty repository is created. That's right. It initializes an empty database, and the database goes inside the .git folder. Excuse me, directory. That happens when you work too much with Windows and start mixing up the terms. Let's move on. PDF. Inspect/dev on your local computer using ls. Which device nodes do you see? Do you have dev input by ID? And if you do, what can you find there? And what input devices do the nodes seem to correspond to? Anyone? Okay, so some of you found your keyboard there. Let's have a look here. Let me bring up my terminal. If I do ls dev, let me add a -l to get some more information. We see a lot of stuff here. And to learn what everything here means would require delving a bit deeper into devices and device nodes in Linux. We're not going to do that in this course. But generally what you'll find up, all the way up top in dev are files corresponding to your hard drives. On my computer, it's these ones, NVMe, etc. Often you'll find device nodes that start with S, SD, SDA, SDA1, SDB, SDB1. They are very typical nodes that represent hard drives. Now, as we talked about yesterday, most of your peripheral devices, most of your keyboards and mice, etc. will also get device nodes that you can interact with. And if I go to dev input by ID, you'll find the microphone I'm using, my Rode microphone, my keyboard, my USB receiver, and my webcam. And you should find nodes corresponding to your input devices as well. Very good. And the last one was about creating a file and using chmod to set the right permissions. So, did you manage to do that? Did you find anything challenging about using chmod? Do you feel like you have an understanding of what it means to chmod a number? To do chmod 777 or 600 or whatever else? Of course, this requires that you keep in your head the information that you need, namely what permissions am I going to set and how do I translate those into numbers. Remember, read is 4, write is 2, execute is 1. You add up the permissions, you get the number. That's the number you use. And did that seem to make sense to you? So if I say that the mode of a file is 777, you understand that means that everyone can do anything to that file. Yes. Okay. That sounds good. Seems like most of you got it, or if not, you're not telling me, which is also fine. But if you did not feel like you got that, go through the lecture notes again, run some tests on your local computer, and try and run some examples, setting chmod 600, seeing what that does to the permissions that you can inspect using ls. But all right, we've gotten through all the exercises that we worked on yesterday, so I think it's time to move on and learn some more material. So let me bring up our slides here. This should be where we left off yesterday. Now, I'm not sure if you remember where you find the slides. Let me just quickly bring up the URL again. This is where the slides are at. The slides have been updated since yesterday. There are a few more slides since then. So write that down and let me switch back to where we were at yesterday. The file system, we talked about standard directories and ownership and permissions. And when we left off, we were talking about octal permissions, permissions by numbers. Now, what we talked about yesterday was mainly about permissions on files. We talked about what it means to read a file, to write to a file, and to execute a file. We didn't talk much about executing files, but we said that executing a file is something you can do to a binary application, to a program file, to the equivalent of a .exe file in the Windows world. Of course, in Linux, there is no convention about having file extensions. So on Linux, you usually won't find that executable files have a .exe file extension. You'll just find that some files are executable. And if they are executable and the executable permissions given, you are allowed to execute it, to run it. Okay, but what we did not talk about is how do we interpret these permissions on directories, because directories also have permissions. Oops. Sorry about that. Directories also have permissions, and they are the same permissions as the ones we talked about yesterday. They're read, write, and execute. And what does it mean to read, write, and execute a directory? So this is a case where Linux is using the same terminology and the same mental model, the same technical model, for something that maybe would have better been described differently. You'll find that a lot, not just in Linux, maybe in any technical field, that whenever an engineer can take something he's already built and repurpose it, he does so, to the detriment of everyone else who has to try and understand it afterwards. So in this case, we'll have to try and think about what it means to own a directory and what these other permissions should be. Now, if you own a directory, say your own home folder, your own home directory, what should that mean? If someone else comes and puts a file inside your directory, should you be allowed to delete it? So what is the purpose of write if you do not have execution rights? Asks Levendahl. Well, not every file on your system is executable. As we said, only applications and programs are executable. Now, you might still want to have documents, text documents. Those can't be executed, but they contain data that you want to keep. if you have write access to a file, you can add to it. You can write, and if it's a text document, then you won't be able to run it per se. It doesn't make sense to execute it. But the write permission is there to give you access to appending to the file, or adding to it, or changing it in a context where execution doesn't make any sense. Of course, you could also be in a situation where you have an executable file which can be changed, which can be written to, appended to. It could be a script, or it could be an application that you don't get to run, but someone else gets to run. In that case, someone could give you write access to that file, but not execution rights. Although I don't quite see where that would be useful. However, what is useful is having write rights and execution rights separated from each other. Now, let's say, why would you have execution rights without having write rights? Well, that is if someone provides an application for you that they don't want you to change. Maybe because they don't want you to change the script that they've provided for you, because scripts, which are text files that can be executed, might contain operations that have to be done in a certain way or order, and they don't want people tampering with it. They might provide you with a file that is executable but not writable. Did that answer the question? Excellent. Now, directories. If you own a directory and someone puts a file there, it depends on what the purpose of owning a directory is, but when it comes to your home directory, you might be pretty miffed if someone came and placed a file in your home directory and you couldn't do anything about it. Root came and dumped a huge 5 gigabyte file in your home directory, and it's stuck there, taking up space. So on Linux, as long as you own a directory, you, in a certain sense, should be able to delete the file, even if it doesn't belong to you, and even if you don't have write or read access to it. And that is exactly what happens on Linux. Let me bring up the terminal. So let's see now. We'll have to demonstrate this. Let me go back out. Let's create a directory. The directory we just created is now owned by me. I have access to it. Let us now put a file there owned by root. So let's just put some content that will literally be the text or string content. Let's put it in a file. We'll look at file and stream redirection later, so this, what I'm typing now, should make more sense to you later on. Let's put that into the directory and call it root file. If we now do ls, ls on the directory, there's a file. I should do -l. Oh, sorry, did I of course forgot to do that as the super user. Now, as the super user, I wrote a new file to the directory. Yes, of course. Okay, sorry about that. There's a good reason why that happened that we'll talk about later. And there's a good reason why I have to do this, which we'll talk about later. Okay. Now I'll have to look back at what happened there and I'll explain it later. some things can go wrong when you do live demonstrations. Now I just created a file as the super user, sudo touch. Touch literally just creates an empty file. Sudo does it as the super user. Finally. Sorry about that. Now we have a file that's owned by root, which I have read access to. As you can see, I'm anyone but root, and I don't belong to the root group. So I have read access, but nothing else. Let's remove that. Let's make this chmod 600. There, now root is the only person who can really read and write to this file. However, I own the surrounding directory. So, even though I can't append to the file, if I open the file, given permission denied, as you can see. If I try to append to the file, that would be to write to it, permission denied. If I remove it, do I want to remove it? Yes. Nothing remains. And I can remove it because I own the top directory. Now, ownership rights of a directory means that you get to remove and list every file in that directory. That is important to know. Now, let's have a look at what the individual permissions actually mean. Because on this directory that I created, you can see that I have read, write, and execute privileges. These are the standard Linux privileges on a directory. Now let's just remove everything. Let's set that directory to chmod 000. Now, no one can do anything as far as permissions go. Let's see if I can list the content of that directory. ls-dir. No, permission denied. Can I change to it? Can I cd into it? No, permission denied. And that's what we'd expect, isn't it, really? We have 0 permissions. We shouldn't be able to make any changes. Now let's set the read permission on that directory. Chmod. There. Now let's see what it looks like. We now have read permissions. What can we do? Can we ls? We can. And that's because that's what read means on a directory. If we have read permissions, we're allowed to list the files. We're allowed to list the names of the files in that directory. But we're not allowed to do anything else. If I try and change to the directory, we get permission denied. So read basically gives you ls privileges, but that's all you get. In order to do anything, in order to really write to a directory, as in to create a file in a directory, in order to delete files in a directory, and in order to be allowed to cd into a directory, you need execute privileges. So if we now do chmod plus u plus x, user plus x, there. We now have execution privileges. We should now be able to cd into it. And we are. We should also be allowed to create a file here. Touch, new file. Oh wait, no we're not. And the reason is because even though we have execution privileges, the write privilege is what allows us to create new files. So although we have execution privileges, which means we can set the folder as our CD folder, as our present work directory, even though we can list files here, we can't create new files. So the last takeaway here is that the write permission gives you the right to create a new file, but only in conjunction with the execute privilege. If the execution privilege hasn't been given, you're not allowed to do anything to the directory, even if you have write privileges. So let's go back. Chmod plus u plus w directory. Now I'm allowed to create a new file here. Now let's go back and let me just reiterate that if you have write privileges but you don't have execution privileges, you're not allowed to write. As in, you're not allowed to create a new file. So now let's say set read and execute. That'd be 4 plus 1, that's 500. There we go. There. Read and execute. Now let's try and create a file. Touch there / new file. Okay. That should not have happened. Okay, did I forget to remove the file that was already there? That must have been it. Okay, I need to go back and check that. I think that I forgot to remove the file that I had already created in there, the one called new file. Can someone confirm that if you paid attention to what I just did? Let me delete new file as the super user. Okay. Now there is empty. I only have read and execute privileges. Yeah. Now let's try touch there / new file. Cannot touch. Can't touch this. Permission denied. Okay, so sorry for messing up a bit there. What happened was that there was still a file inside there that I owned, and I can of course touch anything that I already own inside there. However, when I don't have write privileges, I can't create any new files. So now that there is no file called new file, I can't create it. I can't touch it. Okay, very good. So I know that permissions and settings in Linux, they're a bit nebulous at times. You need to really sit down and read the documentation in order to get the full picture. But the main takeaway here should be that if you want to do anything in a directory, make sure the execution bit is set. If you want people to have write access to a directory, make sure that the execution bit is set. And read on a directory will just give you access to list the content and nothing else. Okay, does that make sense? If it does, we're going to move on. Okay, so another topic that I want to talk to you about is status codes. So this is something that you ought to know about because it happens in the background all the time. When you run a program on Linux and it terminates and it exits, that program will return a code that says something about what happened during the life cycle. Did it exit successfully, or was there a problem and that's why it exited? And that's good to know if you want to troubleshoot applications. If they close down and terminate, you'd like to know if they did so successfully, which means that they went through a normal life cycle as far as the application is concerned, or something abnormal happened and they terminated. So in Linux, whenever a program exits, it'll return a number to the operating system. And that indicates what happened. 0 is the default number. If the exit code is 0, then nothing special happened and everything was okay and peachy. Anything else will signal an error. So when you run a program and it exits, the exit code will be set in the shell. And the status code of the last command is available as a variable, which is just named question mark. And the way you access variables in the shell is with a $sign in front of its name. So when you want to print it, it will be $question mark. Again, with the strange naming in Linux. This is just something you have to get used to. So let me bring up the terminal. And let me just run a completely normal command that should exit without a hitch. ls. I could read this directory. There was no problem. Let's check the status code. 0. Okay. Now, let's try and do something that I shouldn't be allowed to. Something that should lead to an exception. Let me try and read root, the user, the super user's home folder. That's /root. Can't open that. If I check $sign question mark, I get an exit status of 2. Now, if I want to know what that means, I can usually check the man page. Man ls. And if I go to exit codes, it should be down here somewhere. Exit status, here we go. 0 if okay, 1 if minor problems, 2 if serious trouble. Okay, not very helpful in this case, although accessing root's home folder is clearly cause for serious trouble. Now this goes for any command. If you run into problems, remember to check the exit status. That's the takeaway from this. As you can see in my prompt, I've actually included the exit status as the first number. So whenever something happens, the next prompt will tell me the status of the previous command, which is why you can see here, after I did ls root, 2 showed up on the left side. I use these all the time. Okay, moving on. Output and redirection. This is the last topic I really want to cover when it comes to how programs interact and work on Linux. So, actually, this goes for Unix in general. Every single program and application that runs on your Linux computer will have access to 3 so-called file descriptors. That is basically an open handle to a file. So you know when you write an ordinary application and you need to write to a file, you usually issue an open request to the operating system and you get a handle back. If you've done any Node.js programming, you probably know about this. There's an os.open and os.close method, if I'm not mistaken. I think there's something like that. Those will open files and return a handle to them. However, any application in Linux will have 3 handles already opened for them when they start up. And those handles are actually connected to other applications. They provide a way for a program to communicate with the outside world and know that the plumbing that's needed to communicate has already happened. When you run a program in the terminal, it's going to take the standard input handle that exists inside that program and connect it to an input handle in the terminal, so that what you type on the keyboard becomes standard input to that program. Well, at least as long as the program itself decides to use standard input as its input mechanism. The same goes for standard output. Whatever the application provides as standard output will be connected to the terminal and get shown on screen. It doesn't have to be, but that's what happens when you just run a program ordinarily. However, the application itself, it knows nothing about this. It'll just know that it has a few file handles inside that it can communicate. It's like a black box. It exists in a vacuum. It has a tube that comes in, a tube that goes out. And this is what enables Unix to be very modular, because it also means that you can redirect input and redirect output to suit your needs. So the three file descriptors that exist as a standard are standard input, standard output, and standard error. And a normal application will accept input as standard input. It will print normal output. As long as the application was able to do its job, it'll print the output to standard out. If something went wrong, the errors will usually be printed to standard error. And when you just run a program in the terminal, standard output and standard error will usually just be printed in the same window, and you can't really see a distinction between the output, but it's possible to redirect errors, and it's possible to redirect output, so you can separate the two. So let's have a go at doing that. Now, let's again try to do ls-root. There's a message. Something happened. Well, that's really an error message. And we can, if we want to, redirect error output. Just like we redirect any output. And if you had a look at the slide, let me switch back to the slide. You can see that I numbered the inputs and outputs. Standard in is usually given number 0, standard out is given number 1, and error 2. So remember that 1 refers to standard out and 2 refers to standard error. If we want to redirect error output, we use 2 and a greater than sign. And we can now redirect that output into a file, which we can call, for example, error.log. Let's run this command. Seemingly nothing happened, except, as we can see, I had an error status of 2. And now we should see that we have an error.log file here. Right here. And if we run cat error.log, there we go. There's the error output. Cannot open directory. Okay. Let's try and redirect standard input. Standard output. LSL in this folder should work perfectly. And it does. Exit status is 0. Let's redirect this to a file. Let's call it normal output. There, we can't see anything, but there should be a file here called normal output, and we should be able to cat it. There you go. So we can redirect output to files, and that's very useful. If you process anything through a chain of different commands, you might want to save it. And that's a very common application of stream redirection. Now, what we can also do, if we really want to, and there are legitimate cases for doing this, is to discard output completely. And on Linux, there is this special file called the null device, which exists as dev null. It's a device node inside /dev. And if we write to it, the content will just be discarded. It goes nowhere. It just goes into the big void. There we go. We just discarded all that output. Of course, if you don't want to see error messages, you can do that to standard error. There were no error messages in this case. If we try and read root's home directory, there we go. Errors discarded. Let's forget they exist. Now, you can refer to file descriptors on the right side, on the right-hand side of these direction symbols by prepending them with an @ sign. So I can basically redirect standard error to standard input, meaning wherever standard input goes, standard error should also go. So we can do things like ln redirect standard error to and sign standard input. Now any let's have a look here. Oh, ln ls. There we go. Of course, there's no error here, but there could very well be. There will be one if we do /root. It just got printed to standard output. That doesn't help us very much, does it? But if we now redirect standard output to a file, there we go. What did we do? We redirected standard output to a text file and redirected standard error to standard output. And there we go. The error message was cannot open directory root, permission denied. Now, the last thing we need to mention is something that we've seen many times already. It's this symbol. And you've used it already in your problem set, and you've seen me do it tons of times. It's the symbol which takes the standard output of the previous command and attaches it as standard input to the next command. We've already seen how useful that could be by, for example, being able to filter directories using grep. And again with the typos, etc. Grep is just one of those commands that is really the Swiss Army knife of Linux. It's so useful to look at information, filter information, and find information inside files. So yeah, that's output and redirection. Oh right, finally, there's one piece of there's one way of redirecting data that I didn't tell you about. You can also provide data and content from a file as standard input to a program. And then you don't use a greater than sign, you use a less than sign. So we could take the output from our standard output text file just now and provide it as standard input to cat, and we get the output. It's a bit confusing because the content of that file looks like an error message. That's just literally the content of the file, standard output.txt. And the program ran just as it should. We can see that from the error code. But yeah, most programs in Linux will actually accept a file name on the command line as a parameter, which means that you don't really need to redirect the content of that file as standard input, since you can just provide the name of the file as a parameter, like so. And since that is true for most applications on Linux, You might not find any use for this way of redirecting input very often, but it's useful to know about. Okay, so that actually marks the end of all the preliminary information, all the prerequisite Linux knowledge that I wanted to teach you before we start doing bash programming tomorrow. We've looked into permissions, we've looked into redirection, we've looked into small finer details of how files behave and what kind of files you find on a Linux system. Do you have any questions about what you've seen so far? Cowsay error log. Yes, that would be a depressing cow, indeed. Oh. Okay, no questions, I assume, since I can't see any. Okay, so what I'm going to do now, before I hand you, or before you get handed the next problem set, is to give you a whirlwind tour of different commands that you should know about when you use Linux. And I'm not going to cover them in depth because they have man pages, and you'll quickly find out how to use them by using them yourselves in the problem set. However, I've listed them on separate slides so that you have a reference of commands that you ought to know about and what they're used for. So without further ado, let's switch to that slide. Programs and shell built-ins that you ought to know. I'm going to go very quickly through these, and you're going to recognize a lot of them. Just make a mental note of these names for when you get your problem set. First of all, we looked at files and directories. We've seen how pwd will list the present working directory, not current, but present. CD will change your shell's current directory. It'll change the pwd. So that's why I wrote current. It's CD, but pwd. Then you can list content in the directory using ls, and we've used that command a lot. And two commands that you really should know about are cp, which is used to copy a file. You provide the path or the name of the file as the source, and the destination will be the file name of the new file you're creating. The same goes for mv, which is move. And you can either use that command to move a file to a completely different place within the file system, or you can use it to rename a file. So let's just quickly do this. Let me open the terminal. Let me get rid of some clutter by removing all the files here. Shouldn't have done that because I've set strange permissions on everything. Okay. Let's create a file. And let's copy it. New file 2. Ta-da! Move new file 2 to new file 3. I'm being very creative today. Let's have a look. New file 2 does not exist anymore. New file 3 does. If we have a look at new file, and if we have a look at new file 3, the exact same content, which is test, because I am not a very creative person. Let's move on. touch, we looked at that one. Touch will create an empty file with a given name. In order to do the same for directories, you run make directory, mkdir. And a very nice flag to know for mkdir is if you want to create a lot of subfolders and subfolders, you can give it the -p flag, and it'll do the following. Make directory, this is a nested set of directories. And I have to provide the -p flag. And if we do ls, there's a dir called this. And inside this, there's is. And inside is, there's a, etc., etc. Let's go back. -- means previous directory. I think we were 4 levels in. And we're back. Yeah, if you try and do that without the -p flag, you can't. Oh yeah, of course that one exists already. But let's try this is another set. You can't do that because this directory, the second to last, doesn't exist already. In order to remove a directory which is empty, you use rmdir. If you want to remove a file, you use rm. And there is a combination of flags that you ought to know about. That is rm-r. -r will traverse a directory and delete everything inside said directory. So if I do rm-r this, it should delete every single one of the directories that I just created. And it did. And if I do the same to one of these other directories, if I just do ordinary rm, I won't be allowed to. If I do rm-r, I will be allowed to. rm-r will delete the directory and its contents. That is something that rmdir by itself will not do. Let me see, I think we still have a directory here with something inside it. Git dir has a git directory inside it. If I do rmdir git dir, directory not empty. If I do rm-r, it does it. Okay, now here's a very useful one. File. If you find a file on your computer and you have no idea what it does, you can use the file command to try and figure out what kind of file it is. So here, let me switch to my downloads folder. I should have a lot of files here. Reports and books and PDFs. Say I have no idea what the what notes.pdf is. I could run file notes.pdf and it'll tell me that it's a PDF document, version 1.5. Now, of course, if it has a PDF extension, that makes the job easier. But again, in the Linux world, you often find files without extensions. In which case you just have a blank file name and nothing else, nothing to go by. The file command will reach inside the file and try and figure out what it is. There is an exercise that'll show you why that can be useful or how it can be useful on today's exercises or among today's exercises. Now, let's continue. We have a few more to go. We've looked at sudo to run commands as a super user. If you want to log in, to actually log in as a different user, you can issue su and the username. You'll be prompted with a password prompt. Type the right password, you're now that user. Now, two commands that you'll be using on today's problem set are user add, to add a new user to the system, and user mod, in order to change information about the user, say to add a user to a new group. Those are commands that you should look up the man page of. Now, reading, displaying, and editing files, we've seen echo. Echo just takes the text that you provide and prints it verbatim to standard out. Now, sometimes you actually need to edit text on the command line. And there is an editor which I've used already, which is found on a lot of Linux systems, namely Vim or VI. However, Vim is not very user-friendly, in that the first time you use it, you will have no idea what's going on. You will have no idea how to type text, because every single keystroke will be interpreted as a command. And in order to use Vim, you'll basically have to learn things like, in order to type text, I have to press I to go into insert mode. I can write something. In order to save this, I have to press escape and give the command :W to write that, etc., etc. Now, it's a very efficient way of inputting text if you actually learn this form of modal editing, because everything that you do is within reach of the home row of the keyboard. Every single command that you can provide. But it takes time to learn. So a text editor that you should definitely know about, which is provided on most modern systems, is Nano. Nano is a much more user-friendly text editor. You can type text without much ado. And when you want to save it, you can see at the bottom of the screen, there are commands where you type Control-X to exit, Control-R to read a new file, Control-K to cut text, etc., etc. I'm going to press Control-X now to exit. And it's asking me if I want to save this. I'm going to press N for no. So yeah, if you actually need to edit a file, say edit a configuration file, which is something you'll have to do in today's exercises, know about Nano. Nano will probably be the way to go, unless you really want to challenge yourself and learn Vim. Okay, now we've seen cat. Cat takes a file and provides all its content to standard output. The opposite of cat, tac, does the same thing, but in reverse order. Then there's less. Whenever you actually need to read a long file on the command line, and cat will just print out everything and not allow you to scroll. Less will allow you to read the entire file as a pager. So let's see if we can find some interesting file that I should have prepared. Yeah, I think we have something here. So let's take a novel of some sort and open it with less. This is actually The Origin of Species by Charles Darwin as a text file. Now with the pager, you're allowed to scroll up and down with the arrow keys. That's a huge help if you actually need to read a file. Finally, if you want to look for files, there's a file that has a name and that you know, but you can't find it. That's usually find. You can also use locate, which is faster, but it uses a pre-populated file database, which is updated a couple of times a day. So it might be updated. If it's a new file you're looking for, it might not be in the locate database. Lastly, grep, and we've looked at grep already. Pipe stuff to it, provide a query, it'll filter out your query. Now, downloading things from the internet, wget will just literally download whatever's at the URL, and you're going to find some use for that today. in the problem set. Lastly, the thing that I need to show you is SSH. SSH is it's an application and a protocol that you use to log onto computers remotely. Whenever you log into a computer using SSH, you're provided shell access on that computer, and it feels just exactly like your local terminal, save for maybe a little bit of delay. So let me show you how that works. In order to open an SSH session, you run SSH username at whatever host you're connecting to. So if I want to connect to my own personal cloud server, which I'm operating, I could do SSH, the username. I have a user called Christian. The server is available at bjart.ly. That's the domain name of that server. It's asking for my password, which is too long. And I'm in. And the terminal prompt looks almost identical to an ordinary prompt, but I'm now on my server and I can do whatever administrative task that I want to do here. Let me quit. Logging out, connection closed. On today's problem set, you will be asked to log into a range of different cloud computers to find out what kind of Linux distributions they are and to do some administrative tasks. So that was the last thing I wanted to tell you about. That was a whirlwind tour. I'm really sorry. I know that must have been exceedingly boring to listen to. But you now have these slides. You can go back and look at them. If there is a program, an application that you need to use for something useful, at least you have them by name there. You can look them up. Okay, so that's it for today. Any questions about what we've covered today? Can't touch this, indeed. Okay, very good. Now, I think that your instructors, Peter and Michelle and the others, should have problem sets for you. I'm going to be around for a little while. Good luck, and we'll continue tomorrow by looking at bash programming. So thank you very much.